Hey Space fans, so my tradition of Space Apps Toronto this year, we are running just a tiny bit late. We have 10 more minutes until we're starting. We're going to start at 2:25. Now we've got 12 teams presenting, which is really exciting. And we will be
So take a few deep breaths, get a little zen. We've got 10 minutes.
Parang.
It's been a long, long time since Friday evening, but it is time for presentations. What?
I was gonna whisper it to you, but I guess I could just say it in the mic. Guys, how you feeling? Great. This is the moment you've been waiting for. Be excited.
Now, let's try that again, but pretending that we didn't all just get 2 hours of sleep for the last 48 hours. How's everyone feeling? So today, right now, we join, well, perhaps not right now, but around right now, we join 100 cities around the world who are doing this exact thing, presenting their presentations that they've been working on since Friday night or Saturday morning. Over 10,000 people have participated around the world in this hackathon, and we, in a collaborative and friendly way, get to compete with them and to win. So starting, we'll certainly get to how this is going to work and how much in the order of the teams, which is up here, where we'll be shortly. But for now, let's intro the judges.
So our lovely judges will be sitting over here. If you want to note where they are and smile at them very sweetly and endear yourselves to them, here they are. So we'd like to welcome Fareed, who is an entrepreneur and former software engineer. He was a judge for us last year. He's amazing. Everyone say hello, Fareed. Most of us know Beth by now. She has been here all weekend. She's been a real trooper. Beth is joining us all the way from NASA, where she's the Open Innovation Manager. So thank you for joining us all weekend, Beth. We're also welcoming Sabrina, who is the manager of the Weston Family Innovation Center here at the Ontario Science Centre, who will be our third judge. And we have Miriam. If you were at Beer and Post-its, you met her where she led us through an awesome ideation session. She's a senior innovation strategist at Idea Couture and has a really great background in aerospace and engineering. So welcome, Miriam.
All right, so how it's going to work. So each team gets 5 minutes to present. There are radios going off. Each team gets 5 minutes to present, and the judges will get after that 2 minutes to ask questions. You get 5 minutes strictly. You don't have to use all of it, but you cannot use a single second more. Matthew will cut off your mic. Thank you, Matthew. We'll call 2 teams up each time. The team that's going to be presenting right away, in this case, Belt It Out. Hey, Belt It Out. Yes. And the second team, the team that's going right after, we're going to call them on deck. When you're called on deck, you'll come out here. There'll be a volunteer to make sure that everything's working, and so you'll be ready to go right away when the last team's done. We're going to have 13 teams. The 13th team, Rosa, we're going to add to the list shortly. After the first 6 teams have gone, we're going to take a 15-minute break just so everyone can stretch their legs, relax a little bit, yeah.
So we're just going to briefly go over the categories and criteria that you'll be judged on again before we get started. The categories are best use of data, best use of hardware, best mission concept, galactic impact, and most inspiring. The more specific criteria you will be judged on is impact. How much impact, this is quality and quantity, can this project have? Does it solve a big problem or a little problem? Creativity. How creative is your approach? How unique is your idea? Is it something new that no one has done before, or is it an iteration of something else? The next criteria is your product. How well does the project fit the needs of the challenge it addresses? How user-friendly is the technology? Is it a complete solution, or does it have a long way to go? You'll also be judged on sustainability. How good is the plan for the next steps? How prepared is the project team to continue their work beyond the event? Is the project organized in a way so others can take the project to the next level? Which is really important because we're all working on open source stuff here. And finally, you'll be judged on your presentation. How well did you communicate your project? Are you effective in telling its story and why it's important?
Okay, so there will be 5 awards, 1 award each for the best of data, hardware, concept, impact, and inspiring. 2 teams will be sent out to NASA Global for judging on, of course, the international scale or international level. And then we have 1 award that can be awarded to that team or another one from the Ontario Science Centre If you win this award, you'll work with a team at the Science Center to develop a short that will be displayed, a video short that will be displayed on level 6 for the next year to the 1 million Science Center visitors that come each year. So with that, unless anyone has anything to add, let's get to our first team. Belt it out.
Oculus Spectaculus, you're on deck. So head on over to the deck area, which is right over here.
And that is pronounced Oculus Spectaculus. Just F, no.
All right, looks like we're good to go. Come over here so you can be on screen as well. Welcome everyone. Thanks for coming here today. We're from the Belted Out is our project name, and we're doing the Asteroid Prospector Challenge. So just to go over who we are, my name is Kyle Cowan. I was responsible for research and design of the project, and with me is
Teresa Singh.
And what did you do?
I was welcomed onto the team. I was welcomed on the team Friday night. I was here looking for an opportunity, and Kyle collaborated, and I did the play testing and balancing of the game and helped play with it and rebalance the numbers.
All right, so what we accomplished over this weekend is the game actually started out as a single-player, browser-based game concept. When I came into the challenge on Friday, I had some set ideas in my mind. I was going to do, something that could be put into a kiosk. Anyone could just pick up and play it, tap through, learn about asteroids and mining the asteroids and the different materials and that. And then I met Teresa. In the spirit of collaboration, I didn't want to leave anyone out. I wanted to make it so if anybody wanted to join me, I could fit them into the project. Unfortunately, her skill set and my skill set kind of overlapped, and there was not really much space for the two of us to work on the same thing. So I decided to do a 180 on my design. I took a lot of the initial concepts that I had developed, and I'm being pushed towards the mic. Okay. In the spirit of that, I took it all and I made something that was more of a board game style. Well, that was kind of great, but how do you get a board game into everybody's hands? So then we switched over to a card game that you could easily print. So to make it more open and so that anybody could grab it off of the internet and do whatever they want with it, we switched over to a card game, and we altered it a little bit so it would be really low cost for distribution. It only cost a couple of dollars per person to play, which we thought was fairly reasonable. Okay, so all you really need is 3 pages printed off the internet and a 6-sided die or a 20-sided die, and you were set to play. Okay, so this is some of the images from the original game, so you can see what it actually looked like when I had done the initial concept. And then this is what it turned out to be, a card and dice game with various pieces. You can see it on table 9 over there if you want. And it's just 3 printed pages from the internet, hosted on GitHub so anybody can access it, take it, print it, and play it. And it met some of the goals that I had set out for this challenge. Wanted to create something that was easy to play and helps teach school-age children about asteroids.
The nice thing about this game is that, the primary focus is for the mining and transportation. So there's the aspect that of distance travel, so you would go to multiple asteroids, and then you would also collect different types of resources.
Okay. So some of the other goals were low-cost distribution and an open concept for expansion. So really the goal was get it out to as many people as possible, get it in anybody's hands, and make it open for them to take it and really make it their own game. They don't have to play by my rules. They can make up their own rules. They can change it. So if they think that I made it too easy, they can make it harder. If they think I made it too hard, they can make it easier. Okay, and so some of the things that we are going to do with this project from today is we're going to actually take this and introduce it into grade 5, 6 classrooms as part of their space curriculum. My sister and her husband are both teachers, so I've worked with them to help design this concept. We have different sets of predefined cards. So right now on the web is playset 1. We have a couple other playsets that have different mixes of asteroids. We have different scenarios and different expansions coming. So that's what we're going to do. But what I want from you guys, I want you to go to GitHub, fork our repository. Grab a copy of it for yourself. Print a copy of the game. Provide us with your feedback. Send us a pull request to add it back into our game, and then learn more about asteroid prospecting. And that's everything. So thank you guys very much, and hope you guys had fun.
Oculus Rift just needs a few more minutes to prep. So we're going to have Earthy come to our on deck, please, while we have the question period, please. So Earthy, you're on deck at the right side of the stage.
Hi there, just wanted to check with you on GitHub. Is there any of the additional content available of the background information here, or do you have to print everything out to access the content about the asteroids and so on?
So the rule set and the asteroid sheets are available. So it's a PDF that you can print off. It's separated into 2 different pieces. The rules are one set that you can print separately, so you don't have to print that for everybody else. And then it's actually the game pieces. Whatever is there for a single player, you print it off for the number of players that you have.
Okay, so the instruction PDF is included.
Yeah.
Oh, there it is. Thank you. Just saw it.
I have a question for your board game version. So are you still interested in going that path?
You mean
Later?
towards the browser one or the board game?
The board game.
Potentially. I mean, taking some of the base concepts and putting it onto a board, it's still doable. It's not that hard to manipulate it over. But for this weekend, we tried to make it as open as possible.
Just curious for your next steps.
You talked about introducing this into the grade 5. Why grade 5, first of all? And number 2 is, what's the plan around distributing into a larger, bigger set of audience, if you will?
So the reason that we picked 5, 6 was being at the Ontario Science Centre, it's more towards around an 8-year-old kind of thing. So we tried to pick around that age group. In talking with other teachers, there were a couple of teachers that were at the youth challenge yesterday that we talked to them and they said, this is part of our grade 5, 6 curriculum. Can I use this in my classroom? And we said, yes. And so that's why we picked that specific age range. But it can really be used by any type of age range. Little kids, because there is a bit of reading to it, would have to be guided, but that age range is where we set the difficulty.
Thanks.
Hi, I just wanted to quickly rephrase my question. I see the instructional materials here. I guess what I was asking, is there any information for teachers, because I love the idea that you've got it curriculum-based. For teachers, let's say in the elementary panel who don't have that science background, do you have any documentation or do you plan to include documentation on the actual science content?
So as of 2 o'clock, we do not have that on GitHub yet, but it's in my documents folder ready to go up. We do have a section that we're going to put up there, which is teachables, and then we're going to have instructions and adding it in curriculum and doing a quiz afterwards to see what the kids get out of the game.
Awesome. That's all I wanted clarification on. That's great.
So my question, is it done? That's it. Done. Never mind.
Okay, can we have, oh my goodness. No, of course, Earthy, but on deck is Dioresta, I believe. One moment, please. Dioresta, yes, Dioresta on deck, please, and Earthy, take it away.
I can be over here. Hi, everybody. My name's Brock, and I'm representing the Earthy group. We're from Bitmaker Labs, just in the back corner over there. And so we did the Where on Earth challenge. This is our team. So we're 9 bitmakers from the current cohort. And so this cohort's made up of a bunch of different people, but our particular team is a few Canadians, 2 Americans, and one of us is actually from Switzerland as well. So, oh yeah, and here's the disclaimer. We've only been doing this coding thing for about 3 weeks now. I started maybe a few weeks before that with some prep work, same with everybody else, but other than that, we are very new to this whole experience of taking a project from the beginning all the way to its end. So we chose the Where on Earth challenge, and we wanted to pick something that was realistic for our group, but we also wanted to stretch ourselves. And Earthy proved to be just that stretch. What worked for us, we came into the weekend with a great design thanks to the 2 or 3 guys that were working on our design stuff. And also, we had the benefit of having these beautiful images given to us by NASA, and they provide a great backdrop to our game, which we'll see in the demo. Our user interface is really simple to navigate, it's elegant, and it showcases the images that we have really well. And Git worked for us to a certain extent. We managed to have 9 people work consecutively on a project. We didn't have any major meltdowns. We pulled, pushed, merged, checked out, checked in, everything, and nothing broke, which was nice. It wasn't necessarily what didn't work, but what we learned from the experience. Working on a team, most of us have come from either like different careers or school perhaps, and so we had some experience working on a team, but nothing in this sort of headspace, I guess. So we had issues at different times staying focused, delegating the tasks, and sticking to the core goals of the project and the priorities that we had there. And Git was also a learning experience as much as it was a success here. And our organization, so we wanted to stay on top of the goals, we wanted to keep our priorities straight, and we wanted to follow through everything until we were completed. So let's demo Earthy. There we go. So this is Earthy. And this is the interface of Earthy. So in the background, we have one of these images I was talking about given to us from NASA. We have some hints here. So these are just little things about this particular area that the user can interact with and read about.
It's hard to read to say, like,
oh, yeah.
an example.
So the hint for this one is that this was the site of the largest known volcanic eruption in the last 25 million years. So using that hint, the user can go to the, using that hint, the user can make their decision. And, it's not going to be Tokyo. It's not going to be the Isle of Man. I'm going to go Toba Caldera. All right, okay.
Nice.
I actually don't know the answers, so. You go on to the next question. Again, we have some more hints here. So we're looking at this location is the northernmost city on Earth and has the largest number of billionaire residents. So I'm going to say Moscow.
You've got 1 minute, so just...
Oh, I got 1 minute? Okay. All right, I'm just going to get every answer wrong. No? Central Mine, probably not. No. And we go through about 6 questions here, and the scores are stored, and we'll see by the end. Oh, I totally took over your job.
Don't worry.
Okay.
You can keep talking.
All right. So then we get to close to the end of the game. Yeah, here we go. And then we get a result. We get a summary of what we get. So
we're pretty much done.
We're pretty much done now? Alrighty.
What's the last page?
This is where we'd like to take Earthy. So I think it would be great in a classroom for middle-aged school children. It's probably maybe a little advanced for younger kids. We'd also like to integrate live images, and we've reached out to a couple of different contacts to get that started. And I want it to be used in space, but it's probably never going to be. But I doubt the astronauts would actually get a perfect round too. So anyway, thanks for having us, guys, and we're really happy to be here. Can I unplug here? Or? Yeah.
So I have a question for you before you guys leave. Did you, for the hints that you had, did you get that from the NASA data that's attached to the image, or where did you get the hints? Did you come up with them?
We didn't get all of that. We're getting this from the rest of our teammates back there. So some of it, yes.
Yeah.
We look for other sources too. Like obviously Wikipedia is a great source.
Yeah,
No, that's a great, yeah.
We basically split the assets that we had
Yeah.
and among the team, and then we all did.
Yeah.
Sorry.
No,
Then
I
we
don't
all
mean
did
just
our-
you. I meant your team. So I was just wondering how. Yeah.
Like
Yeah.
some of the information is attached to the images.
And the other thing I would just say to you, because I've done a lot of these at NASA, we can't store student information. So what you'd need to think about on the back end is either encrypting or dumping, like having just the first name. You know, if they're under 18, have a little click button, and then you just don't share it. You know what I mean?
Yeah, our cookies are, or like the first name is the only thing that's stored, and it's
Got it.
stored locally for just the one session. So we have our cookies set up so it dumps every time the session finishes.
That's awesome.
Yeah.
Can you hear me? What's your plan for the next iteration of the game?
I think that we'd like to extend it. I was talking to, I'm actually not sure if he's here today, but I was talking to someone who was here yesterday that pointed me in the direction of Earthcast, which is using live satellite imaging, and so we'd like to reach out to them and make the images live images so that they're current and something that people can learn from. And then we'd also I'd like to kind of demo it back at BitMaker Labs, get some feedback from our instructors, and kind of take it from there.
Yeah, because I see a lot of value in potentially even connecting that with where that satellite possibly is and using it as an educational tool for people to know what technology is actually capturing all of these images.
Cool, that would be great, yeah. All right, great.
All right, can we have Weather Mesh up on deck, please? And just a quick something to let you guys know. There's also, actually, we forgot to mention, a People's Choice Award. So pay attention, of course, to the pitches, because at the end we're going to give you a link, and we'll do a poll, and we get to choose our People's Choice Award that, again, gets sent up to NASA for to win a global People's Choice Award. So if you've got a team that you really, really like, make sure you know their name, and you'll definitely participate in the poll. So in the meantime, let's have Dioresta.
Maybe. Sweet. Check. Yeah. Awesome. So our name is poorly spelled backwards. Dioresta was a very quick 30-second name for against our team, and it's supposed to be asteroid backwards. It's close, pretty close. Anyways, so I'm gonna pop this open. Let's do full screen. So, right, so it's supposed to be asteroid backwards. It is not. This is our team. Well, actually the two guys over here that are in Snuggies or whatever are the owners of a company, or the founders of a company called TWG, and these two young fellows here are a part of that company. And I'm the one on the left. I am Darcy. So essentially we are team TWG and Darcy Clark. So we got together, and the challenge we were working on was the Asteroid Prospector challenge, which seems to be one of the coolest ones out there, and something that I had the most knowledge on, so it was something that we want to tackle. So we were looking for a solution, essentially that would be really cool. The end game for us was hopefully to have our project be showcased in the Science Center. So we wanted to make something that was fun as well as educational, and it had to look really cool and have some cool functionality for kids, adults, and people of all ages. So this was the interface. So the screen you saw over here was some of the first concepts that we sort of came up with for how we were going to approach sort of a cool, fun game that would also help educate and teach people about the makeup of asteroids, and also, you know, talk about the impending doom that if a huge asteroid came knocking on Earth's door, what would happen. So we created a great interface that we actually have on 2 of these iPads. And the idea was to have 4 essentially tablets sitting in front of a big screen. So you could have 4 spaceships all basically mining one big asteroid, trying to get it to a small enough state that would be just a blink in the Earth's atmosphere, and it would burn up in the atmosphere. So along the ways, you would get different minerals mined from that. So we're actually going to do a demo here quickly. And we used some really cool technology. We used Node.js, WebSockets. Everything is on GitHub. We actually had another member of our team do a lot of research into the different minerals that were... Oh, okay, so I'm being told to speed up. So a ton of information that we used here on our GitHub page. We worked together and collaborated on it. But we will get to the game demo. So let's do this. Sweet. So this is our game. These guys are going to play. So we have a little bit of a story going on. There's this urgent transmission. Essentially, we have this great little professor guy. All this was animated and designed over the past 36 hours. I haven't slept much. And this little guy's telling you about this impending doom of this asteroid that he's found. He actually works for NASA with the Near Earth Object Program. And he's telling you that you are one of the few that can actually help stop this asteroid from coming and breaking into our atmosphere and killing us all. And he talks a little bit about how big and how much time we have before this asteroid hits.
It's going to go quick, don't worry.
It'll go quick, yeah. These guys are really good at this game. There's some really fun controls which you guys can play with later to actually, it's pretty cool. So now he's like, go. Okay, sweet. So they have to see my screen, so here we go. So as you can see, they start drilling into the asteroid. And they're getting minerals as they sort of get down there. They're tapping furiously and trying to line up a little drill on their screens. And all the while, they're getting little minerals are coming off and trying to make this little asteroid a lot smaller. So they're getting close. They only have about 90 seconds before this all blows up. Oh, and they've saved the world, which is amazing, right? And you get a nice little scoreboard. So you're sort of working tandemly, which is a lot of fun on a common goal, but you get a nice little score afterwards so you can sort of compete with friends and something that you can do multiple times. Awesome. Sweet.
Hi guys, congratulations, this was great. So just obvious question, what's next for this game?
Fixing the bugs would be a good start. Obviously we'd like to clean it up and introduce, one of our big goals was to introduce some more educational material about asteroids and specifically mining asteroids. Unfortunately we couldn't get some of the stuff that we wanted into the game, so that would be one of the next steps for sure.
Okay, and secondly, what was the toughest part about this challenge?
Actually making the game.
There was a lot of facets. We had a ton of things we wanted to do. So the challenging part was sort of reeling in all our great ideas. We wanted to actually have it so that anybody could join in on the game and almost... Essentially, we had big aspirations. We wanted to have, because we're using sockets, anybody could join in the game, and potentially we were going to have two different interfaces, one for the actual 4 people that would be playing the game in the starships, and potentially somebody that could go on their mobile phone and hit a website and join in or give bonuses to one of the 4 different players to essentially help them drill faster or to give them sort of bonus points. So that was one of the key things we wanted to do, sort of to engage a larger group and to sort of see something that had bigger data behind it. But yeah, essentially, I think the biggest challenge was that. I think we had the skills we need to do everything else.
So I don't have a question, but I have a couple suggestions, which I've shared these. But if NASA uses this at some point, we can't kill people, and so we save the world. You don't ever die in a game, just so you know. And the other thing is, I would have your professor be a female. But that's just me.
It's actually based off a little kid who came to go see us the other day. I have a reference photo, so he's somewhere. He came. He was at the youth event yesterday, so he wanted to be a part of the game. So.
That's it?
Thank you, guys.
Thanks, guys. That was really awesome. We've got Weather Mesh up next, and Astro, you're on deck. So please come to the right side of the stage and get set up. Weather Mesh, take it away.
Hey, our project's called Weather Mesh. The team is myself, Tessa, Nicole, who couldn't be here, and Camille. We decided to take on the challenge of Cool It, which is to help monitor the temperature difference between urban and rural areas. It's also known as the heat island effect. We wanted to find a better way to more efficiently cool down urban areas where everybody's running their air conditioning. We might get a brownout, stuff like that. So the solution was to build a small device, this here actually, and have an API to store that data. The API was built with Node and Mongo, which was mainly Tessa, and the front end was done by Nicole and Camille. And there's the Arduino-based weather station. Sorry. Some of the challenges were getting the hardware to communicate with the API. That was pretty tough for us. And then building out the front end maps, which Camille had a lot of trouble with. It was pretty interesting to play with the maps and try to find ways to get dots on those maps and just start there. And then our entire scope of our project, it started as just getting this small hardware device to communicate with the API. Then it became a website, and then we wanted the website to be kind of the Facebook for temperatures, where everybody can build their home weather station and start to input data. And I think that's where the future's headed for this project. This is the weather station itself. It's based on an Arduino Red board because it's pretty inexpensive. The wireless board was probably the most expensive part, but still pretty doable if you wanted to mass produce these. A tiny humidity sensor and a barometric and temperature pressure sensor, which is actually does -40 to 120 degrees Celsius, which is pretty awesome because that was probably the best one I found out there. Yeah, so and now we have our demo. Did you want to take over?
Okay, so let me just pull up the demo here. Okay, so this is a currently working version of our map, just displaying sensors around the area of Ontario. And currently it's actually pulling or getting data from the current JSON file, which Heather and Tessa can speak to a little bit more. And again, for every single sensor or data point, we have the information that you can hover over and receive in real time. So currently we have the current temperature, which currently about every 10 or 11 seconds updates. So again, Tessa can talk a little bit more about how that was set up. And we've already talked a little bit about the challenges of setting up D3. This is the first time that we've really worked with this library. So it was a little bit of a challenge, but I think overall the future would definitely be showing all of this data not only in real time, but also comparing it by time through an animated scale. And again, the more data that we get and the more people that participate, the better and stronger this app is. So that's pretty much it for the demo.
So we decided to make like an open API that eventually anyone who could create one of these basic weather kits could connect it to our API so that we could display data from potentially a lot of different sensors, and then ideally if you had them all over a city or all over an area, you would actually be able to see the differences in temperature between different areas in like a microclimate. So the way it works is that if your weather sensor, ideally we're thinking you'd have to like get an API key to be able to connect, but you make a post request to our API, and then your sensor becomes one of the sensors in our system, and so it can start sending data, and then like your sensor would appear on the map and start transmitting the data for temperature, humidity, and barometric pressure, along with all the other sensors.
Yep.
Is that everything?
Yep. Oh, that's all good.
Alrighty.
Yeah, so I think we're ready to take some questions.
Okay, I've got a couple.
Sure.
Now, did you intend to have people have a version of that or make their own one of those?
This is completely open source, and all the pieces are open
So
source
you'll
as
have
well.
the design for that so people can set their own sensors out wherever they live,
Yeah, they
right?
yeah.
Okay, and then so I just see that as a product in itself at some point.
Yeah, it is
that
for sure.
You create your own, and then people just order them from you. Those
Yeah.
who don't want to build it can just order their own island, you
Yeah.
know, and take that.
That's definitely the starting point for us. And I think we just want this to be a starting point for people who might not be able to buy it from us, or they can just build it themselves or put their own spin on it and build it the way they want it to be.
And then the data set that you had trouble with, what was the data set?
Oh, so that was building out the maps.
Oh,
So I think
building.
that Camille can speak.
Yeah. Again, it was the first time that we had worked with TopoJSON and GeoJSON files. So just getting the shake files from natural Earth data, which I believe was the biggest challenge, just getting them into QGIS and just figuring out how to convert that data was kind of our biggest challenge. But beyond that, it was, again, just dealing with figuring out how to set up the data points right now as we go. So.
Just a quick question. Great idea, or comment rather. Great idea about. I see a lot of potential for classrooms as well, especially in an environment like here at the Science Center. Did you mention the estimated cost for the kit and production materials and so on?
The prototype cost about $100, but that was because this shield is more expensive than the smaller type. I think we could get it down to around $40 to $50.
Okay. Thank you.
And that's it.
Can I just pull this out? Yeah. Okay, great.
Thanks, WeatherMesh. Astro, you're up next, and Enterprise SSB, you're on deck. So please come to the right side of the stage.
This has the script, so maybe that one right would have.
No, I need to see both. We can just use handheld.
You need the mic.
Cool, you ready to get started, Mike? No. Is it good for you? It's as big as it is. Because the rest of it's really short. Pick it up? Yep. Pass the mic to me next.
Hi, everyone. While we're introducing ourselves, if you don't mind visiting the link on the screen.
Cool. And you can visit that link on a smartphone, tablet, or desktop computer. Just have a look at it for now. It'll get interesting once we get into our demo, but go ahead and get yourself oriented and get there. So just to introduce myself, my name is David McCabe. I'm a product manager from Pivotal Labs here in Toronto. I do a lot of work with mobile applications and excited to be part of Space Apps.
Hi, I'm Farhan Namani from Idea Couture. I'm an electromechanical designer, and for today, the astronaut on stage.
Hi, everyone. I'm Mike Stern. I'm the team lead and founder of MakeWorks.
Hi, everyone. My name is Karmanya. I'm a mechatronics engineer, and I have a startup in sports and analytics.
Hey everyone, I'm David. And I'm a software engineer from Pivotal Labs, and I worked on Android and Glass stuff this weekend.
Hi, I'm Andrea, also a software dev from Pivotal Labs, and I worked on front-end web.
Hi, I'm Samir, and I worked on back-end development. I'm also from Pivotal Labs.
Support team right there.
Okay, first, by a show of hands, how many people would love to go on Elon Musk's next SpaceX voyage? Awesome. Now, how many people, by a show of hands, can afford it? Maybe one or two. Don't be shy. Our big assumption is that we're entering a new era of space travel where most of it will be done privately and by the very wealthy, and that they won't necessarily share their experiences or interact unless it's really easy, fun, and maybe a little competitive. So meet Astro, a platform for space tourists, or what we call Astros, and Astro fans here on Earth to connect and create inspirational space experiences together. As you'll see, it's kind of like Ask Me Anything, but designed for space. And we built this because we saw an opportunity to enable public engagement and co-creation back here on Earth by intentionally designing a seamless sharing experience, leveraging sensors and wearable technology.
Cool. Now I'd love to take a minute and do a demo. So hopefully you guys are already on bit.ly/Astro2014, smartphone, tablet, or desktop. And let's have a look and see what you guys are likely seeing. You guys are likely seeing this page, the daily challenge. So one concept in the Astro product is the notion that us on Earth, you know, there's many of us, there's very few of these rich people who got to go to space, and we want to give all of us an opportunity to somehow interact and communicate with them in an interesting way, an interactive way. So bi-directional, essentially a many-to-one chat application. So the idea is with the daily challenge is anybody can submit an idea to the daily challenge, and everybody can vote up or down those ideas. So hopefully you've already started clicking on things and submitting your vote for what you'd like the astronaut to do. As we see in 55 seconds, the polling's closed, but in actual fact, we'll probably look to close that polling probably right about now. So what happens when the polling closes? If we have a look, we see Macarena's in the lead. Yes, lucky astronaut. The astronaut gets a notification on his Google Glass. So, astronaut.
So I wake up in the morning and I want to see what the daily challenge for today is. What do people on Earth want me to do that would make me popular? Let's be real here, I'm kind of a narcissist. So, it's do the Macarena. All right. Now when I'm outside on the moon and I finally decide that, okay, I want to actually take this opportunity to make it happen, I go there and say, sorry, demo glitch. You got it? No, it's sorry. Oh, sorry. Okay, Glass. Record a video. So this is my 10 seconds of fame of me doing the Macarena.
Macarena, hey, Macarena.
Thank you. All right, okay, Glass. Share with public. Okay, Glass. Add a caption. Hey, Macarena. All right. And that's it. That's all I have to do as the astronaut to share my experience with Astro.
Awesome. So now that means the video is submitted and everybody on Earth can enjoy it and have a lot of laughs.
Okay, so 2 more. Okay, 30 seconds. So as you can see from this screen, this is the Astro view where you can see your different astronauts as well as some important vitals, so you can really feel like you're part of the space experience. For the last few days, our mechatronics and electrical design leads spent at plotting out the appropriate wearables and sensors for space tourism, and then mapped it out against currently available NASA data. The results were interesting, but not surprising. Current data is very focused on research and exploration, but not tourism and adventure. What happens if you open that floodgate of space tourism data to the public? Meet the Astro API. Once you have all this data, how can we get other people on Earth to create new experiences with it? We can think about scenarios in health and wellness, sports, entertainment, culture, and the environment, leveraging this new data set from a new type of space travel experience. In conclusion, Astro is not only a fun platform designed for new space travel, but perhaps more importantly, Astro exposes a new data set for others to co-innovate on and inspire the next innovations in space. Thank you.
I've asked them so many times. Just wondering how you're gating the solutions that people offer or moderation of any of that?
Excuse me.
I'm just wondering how you're gating the solutions, for instance, people suggesting various types of things.
Yeah, so that's a good question. We talked a little bit about that. We didn't have time to build in some of those different moderation tools, but I think it's important that what we thought about is important, that we want to balance both this kind of open concept, ask me anything chorus style thing, and make it quite open so that people really, get into those new eras of, goofy, whatever that's going to create the new innovations, but at the same time have some moderation tools behind the scenes. So definitely consideration, but not enough time to build it.
So for a company that owns the hardware, for the private company that flies people to space, I'm just trying to understand what is the innovation here from the perspective of collecting data and sharing it to the public. What other innovations are you guys thinking about building or utilizing from that data, knowing how challenging it is to access it?
So there's two ways to look at it. One is, perhaps this is a tool that NASA owns and that, SpaceX and Galactic leverage, but it's really just an open platform. In that sense, then, the technology is already available, and it's just a matter of creating or designing the right kind of interface that gets people actually excited to use it. From the perspective of, let's say, Branson or Elon wanted to license this, there's still a lot of value in making the data open so that other people can innovate on top of it. Does that kind of answer your question?
Kind of, yeah. Okay, so they're going to try to cut us off. I have not a question, but a comment, because I usually have comments. I would split the two, because the first part about having people have the astronaut do the Macarena is awesome. It's totally different from the second half, which is the collecting data from the tourists, which is I think you were doing, and making that available and using that to kind of interact with life on Earth. And that is awesome. So sometimes you try to put too many things in one thing. I would love to see that other screen to see know more about that second half, just because I think there's a lot there. Yeah.
Yeah, we're definitely a little short on time on explaining the second half. The idea is that set of APIs and a way to make the data, all the data that's collected today and put in multiple databases, a way to kind of bring it together and share it in a meaningful way so that it's easier for people to use that data and build applications that would interest the average person on Earth.
Yeah, one thing we do want to do is we did miss a couple of slides and some diagrams that we'll share, and it's all on the repo, so you can see some more of the thinking behind it.
Okay, that was really cool. But it did go a little long, so I have to issue the announcement that if you could please keep your presentations to 5 minutes, that would be great. We will start unplugging the mic without warning you, so that's the thing we're going to do. Enterprise SSB is up next. Burning Set, you're on deck, but we're going to take our 15-minute break between Enterprise SSB and Burning Set. So please come up and be on deck as you would as normal, and then feel free to take 10 minutes. So, Enterprise.
Greetings.
So I think you're probably going to have to be on my left, and that works. Hello. So welcome. We're Enterprise SSB, or Enterprise Save Sandra Bullock. I know, it's funny. Our idea is actually based on that movie. So what we're trying to accomplish here is to prevent astronauts to drift away out of control and provide them a way to find their way home safely by the use of wearable technology. So currently, and in fact, the target that we're trying to aim to is space tourism. Let me move on. So space tourism, it looks awesome. Like, I can't wait. It might look something like that. It might not. But the truth is that most likely, maybe in the future, maybe in 100 years from now, the space tourists might actually end up doing spacewalks. And that can actually lead to disaster. So this is a scene taken from the movie Gravity, where unfortunately Sandra Bullock drifts away into space in an uncontrollably fashion, and she cannot stop herself from spinning. Reason why is because there was nothing for her to push against. Doesn't matter what she did, doesn't matter how much she moved, she couldn't compensate for that reaction that was happening. One thing that we are taking as an assumption is that these astronauts, these tourists, will be wearing jetpacks. And those jetpacks will allow them to be able to move in space. Now, two things could happen if this event were to happen. They might land somewhere and start a new life, or most likely they're going to struggle and they're going to be really suffering. So it's super important to bring them back home safe. Now, this is the challenge that we approach. It's called Space T. Our problem is space tourism might accidentally drift away from safety while on a spacewalk. A space tourist lacks of proper training to operate the jetpack. So the solutions that we're proposing is through detection of reaction motion to operate the jetpacks and bring those tourists back home to a stable mode. After that, allow them to navigate back home or to safety through the use of hand gestures. Let's talk a little bit about the hardware that we use. The first piece of hardware is the leap motion. It actually detects hand movements, and we can actually operate commands based on those hand movements. The second one is Kiwi Wearable, which has an accelerometer and a gyrometer, which means that we can actually detect the actual motion of the astronaut and predict what exactly they're trying to do, and be able to compensate the jetpack based on that reaction that the person had. So we also custom design, and actually passed it around, and you can see Kyle wearing it. We custom design a bracket, an arm to hold the leap motion, so these people will be able to literally operate it right off the suit. Let's go straight into the demo. Two things I want to show. The first one is I want to show you how the tourist, the astronaut that went and is drifting away, and Kyle is going to demonstrate right now how we can actually record the reactions. Go. Yep. So he's going bananas, right? And if you can see on the screen, we were actually able to record the data and get everything, the acceleration on X, Y, and Z, and the gyroscope position on X, Y, and Z as well, which means that we can actually use that data, even though the astronaut might not know, or the tourist might not know how to operate the jetpack, but it's instinctively trying to do the opposite motion of what's happening to them. Let's say they're drifting backwards. They're going to try to bring themselves forward. We can use that data to correct their positioning and bring them to a stable mode. Now, the second piece is once they are in a stable mode, we need to bring them back home safely. So they can actually operate the, go ahead, Kyle. So as you see right now, the astronaut is going forward, and through hand motion, he's being able to drive himself back very, very easily to safety. If for any reason they need to go backwards, they can actually reverse. And now they're driving backwards. And again, once they bring themselves back home, they're going to be safe. So, That's about it. This is Kyle. I'm Alejandro. We're Enterprise SSB, and we're open to any questions you guys want. So leave the stuff there. So, yeah.
Okay, so I'm not going to ask a question. I'm going to make a comment again. I think that this is awesome for people who have stability problems on Earth. And so being able to measure, when people really have inner ear problems or, they're really having trouble, I could see a lot of Earth applications for that, even if it never goes to space tourism. But what you guys have put together in a short time is awesome.
Thank you. Actually, another application that someone approached us said this could actually be very useful for scuba diving. Scuba divers also lose balance very easily, or at least orientation. And this could allow them to find themselves back to balance and continue operating. So absolutely, there's many, many applications for Earth as well. All right.
Awesome.
Okay, so we're going to take our 15-minute break. Burning set, if you're not set up yet in the on-deck area, please do so now. We did call you on deck earlier, so 15 minutes, then we're going to get back to the presentations. going to need Skywatch on deck. Skywatch, you're up next, so please come to the right of the stage. Get ready. Oh, hi, Jonathan.
Hey, Emma.
How are you?
I'm great.
Okay.
Those are some great presentations.
Yeah, there's a lot of cool stuff being made.
Yeah. I'm amazed at like what people are able to accomplish in like 24 hours or
I
36 hours.
can't do anything in 48 hours, so props to all of you. Do you want to give yourselves a round of applause so far? Yeah. All right, Burning Sat, it's your moment of glory. Come on up.
This is the fire we know. But these are the fires that kill. Fires are slow fires with no flames that release toxic and often lethal gases. They can go for a while without being detected, and they're responsible for about 25% of all fire deaths in the United States alone. This is where I study. My name's William, and I'm a fire scientist at the University of Waterloo, well, a student. That rusty thing on the right side of the red building is about 2 stories tall, and those silver cylinders on top of the red building are very powerful fans to pull out the smoke in that building when we're doing experiments. A couple weeks ago, I was doing an experiment. I was burning about a cookie sheet full of peat. I went in about halfway through the experiment, donning my protective gear, of course, and flies were literally dropping from the sky. They were dying of carbon monoxide poisoning from a smoldering fire. Imagine what came out of this mattress. They're dangerous, but so what? Well, 1 in 10 space shuttles have had charred wires. Charred wire incidents. You might wonder what that means. This is a charred wire on an automobile. You can see the wire that the hand is holding. It's burnt, it started to smolder, and it could have started a fire. It starts fire on Earth, and it could start one on the space station. Thankfully, no fires have been started in space, but it is still a risk. A NASA safety briefing reported that these kind of ignition sources, arcs, sparks, and wires, happen all the time. Well, often. And it's something that does start a fire. It's a big risk. Fires in space are absolutely catastrophic. There's absolutely nowhere to go. Now imagine a world where space travel is as common as flying to New York or Edmonton. A $1 billion industry. I'm looking at you, Virgin and SpaceX. It's your job. We need to understand how these fires behave in space so we can learn to detect them and put it out. Well, after a lot of reading, I have discovered that these kind of fires are not well studied in zero gravity, smoldering fires, that is. The best we have done is a small sheet of paper like this. Doesn't tell us much. To find out something, we have to burn something like this. And that will give us good information. But no one in their right mind would let us do that on the International Space Station or any manned mission. Remember this? So I looked into building a CubeSat that would allow us to do this in space. The burning sat has no risk to human life because we can't fit on one, and so much valuable information could be gained. It would cost about $12,000, $13,000 to buy the components. Total weight comes around 50 kilograms, and it would consume about 120 watts of energy at any given time. And everything would be relatively small. Yeah, relatively small. All off-the-shelf components, you could go to the store and buy these. So it's completely doable. It would carry 4 blocks like this to do 4 experiments, and they would be, they would look like that on it. They would be positioned in such a way, and you would be able to perform experiments independently on the blocks. And this would allow us to get that much closer to understanding more about these mysterious smoldering fires. We would find out how to detect them as early as possible in space and here on Earth. What we learn up there would not only be useful for the explorers of the final frontier, but also on our planet. Scientifically, these experiments would give us a simpler case to study. Removing gravity as a variable would allow us to simplify our models, and this would allow us to understand or to focus our attention on smoldering mechanics, which are so poorly understood. Back to Earth. Fires on plane usually start out as smoldering fires, in fact, charred wires like we saw in the space shuttle. What if we could detect smoldering fires before they cause a major problem, before the plane has to do an emergency landing? How about at home? There's two people I'd like to thank, especially, apart from everyone else. One is Heather Fraser over there, a fire suppression, going to fire technology, who has helped me a lot. And the other one is Ross Gillette, who has helped me a lot yesterday, and without them, this presentation would have been possible. Thank you.
Okay. So how would you smolder in your CubeSat? Well, how do you start the smoldering?
Well, since we can produce these samples chemically, I was thinking of putting a nichrome igniter at different locations within the foam. So you could actually start it from the center and see what kind of effects you would see on the outside initially in the fire. Or you could put it on the outside. You could also build in thermocouples to measure the temperature.
So do you put sensors all over, inside and out? How, is it like is it covered in sensors so you know where and when, or how are you measuring?
Well, you would be able to impregnate the cube with sensors, well, to a fairly low density because you still need appropriate combustion mechanics happening. The other sensors, which would happen, I'm working on a design for a smoke detector, but an optical smoke detector which would measure the density, and building an array of lasers and photoreceptors on two planes would allow us to actually calculate where the smoke is and how it's emanating from the cube in low ventilation environments in zero gravity, as well as thermal imaging cameras, regular cameras, and gas sensors, of course.
So if this technology is validated, let's say we fast forward a few years from now, how is this going to pick up smoldering fire in a bigger, larger volume and environment?
Well, right now, one of the biggest impediments to detecting a smoldering fire is that it is so poorly understood. We don't understand smoldering fires. So if we understand how they behave, especially in zero gravity environments or on Earth in our gravity, so where you have convection mechanics, then we would understand where sensor placement is important and which things to look for out of the fire. Thank you.
Thanks, William. That was great. Who knew we had a fire scientist in the house? That's awesome. Skywatch, you're up next. And Insight, you're on deck. So please come to this area, get set up, and we welcome Skywatch.
Testing. Put your phone? Yep. I need your phone. I'm just going to use mine to talk.
Sweet. Oh, other side.
No, I want to speak in front of the judges. So we switch after. Okay, there. Can everybody hear me? Does this work? Okay, awesome. We're good to go? Okay. So we are Skywatch. I'm James. So to tell a quick story, in ancient times, whenever there was an event happening in the sky, which was rare, it was either one of two things. It was either a revelation or it was a warning sign. But with modern technologies, we've now learned that there's thousands of events happening in the sky every day. And we're looking deeper and deeper into space to understand the foundations and the origins of our universe. And that leads into our challenge. Our challenge is to create a website that is accessible and easy to read by the mainstream media that can sort of communicate these transient events that happen on a daily basis and make them accessible to the wider public. And for example, what are some of these events? They are going to be gamma ray bursts, they're supernovas, they're passing asteroids, they're gravitational microlensing. So these are a lot of things that we're not familiar with. More so, a lot of the language that's used to communicate between telescopes is something that we're very unfamiliar with too. So we actually didn't begin building until almost about 24 hours ago, really. So everything we have, we built in 24 hours because we had a huge learning curve. And when you have a huge learning curve in this situation, you sort of do what it is that anybody would do in this situation. We contacted an astrophysicist at NASA. We came across his contact on a lot of websites with these transmission protocols. So I contacted him. And we were in email communication for the last 24 hours. He sent us lots of information. He sent us IP addresses to databases that NASA had to use that was open source. And we pulled some of those, we took a snapshot, a small snapshot of one of those databases. Since it creates about 3,000 events daily, we just needed a small snapshot for the demo we're going to use today. So we focused on one specific transmission protocol, and those are called VO events. Essentially what happens is when an event happens in the universe, and one of the satellites or one of the satellites in the air or one of these satellites or radio sites on the ground picks up these changes, it communicates them to all other satellites, or sorry, all other telescopes, for those telescopes to then point their telescopes at this event occurring so that we could have multiple recordings of this event taking place and multiple measurements. And all this happens from 3 to 5 seconds of when that photon hits the sensor, the stream shows up on our website. Okay, so this is what we have to compete with. This is called Sky Alert. This is what scientists are currently using. And I'm going to quickly show you, well, Ryan is actually going to quickly show you what it is we built.
Does this work?
And I'll just say that we wanted to create something that looked like a Twitter stream, so our subtitle is A New Way to Follow the Stars.
So this is what the page actually looks like. It's broken up into two major components. We have the component on the right, which is the actual stream of information coming in. Like as James said, we're just use a snapshot for now, or it would be very, very hard to follow. But normally this would be real time. And on the left, we actually have a visualization of this data. On this map, we will actually plot the location of the observatories sending out these events. And the really cool thing, thanks to our teammate Roland and his genius, we are actually able to click on this tag here and plot the coordinate in space. And you can zoom in using Google Sky. Let's let that load, and you can get an idea of what it actually looks like where this event is happening. And then if you want to filter the events, we have a quick little filter box here, and you can subscribe to it via email, RSS, and we can even tweet at you if you really want to. And we intend to keep a Twitter hashtag open as well. And the final thing, I can go through this quickly. If you're an amateur telescope person, you can actually take the coordinates here and this little visibility meter that we put based on the cloud cover in your area, and you can actually now point directly at this event as it's happening.
In real time. Okay, so why is this important? Well, with my last 10 seconds, I just want to say, in order for people to start thinking about space, they need to be able to see it, and they need to be able to understand what's happening. And with that, they become inspired and come to events like this, and we create huge movements around that. So with that, thank you very much. Hi there.
Not turned on yet.
Not oh, here we go. Excellent. First of all, from my perspective, which is informal education in museums and schools and so on, really awesome idea. I have seen Sky Alert. As you said, it's aimed at scientists, so having something that's user-friendly for the general public. A couple of observations. would make a great kiosk application because of the fact that I haven't really seen a lot like this in museums. So that's one thing you might want to think about. The other thing is the actual interpretation of the content. In other words, it's great to have all these people contributing and seeing all that. If you could upvote, for example, simple explanations of X number of words of what they're looking at and why it's important, that would make it a much better application on the floor for visitors of various ages.
Yeah, what we actually cut out was something that we began working on, which was an about page. So if there was multiple events, multiple interactions about one event, it aggregated. So if there was tweets, if there was photos, video, social media, stuff related to that event, we could actually aggregate it to keep sort of a consolidation of events related to, or of media related to one particular event. So yeah, we also have a tooltip that when you actually hover over that point, it gives you more information about not only that particular event, but what a supernova means, for example, or what a gamma ray burst is.
And that would be great. And one thing we see is that in a lot of these types of vendors that come to us, for example, they have this content and this great consolidation, but the science communication part of it is where it usually falls down. And having that ability to tell people in a very quick burst of information really easily what they're looking at and why it matters, that's key, I think.
So I have a couple comments too and a question. I think this can go to the App Store right now and would be completely viable. Absolutely. You probably have already sent it. Okay. And then who did you work with at NASA?
Scott Barthelemy, thank you very much. I'm pointing at the camera, no one has to look, but thank you.
Right. That's cool. Wow, that's cool. And then the other thing, just to let you know, spaceweather.com was started by science at NASA, and so they do have, that was the first website that we had where we allowed users to send us information. Now it's run kind of separately, but that's, you've probably already linked in with them, but they've got tons of information that you could also link to with this.
Great.
Awesome.
Thank you.
Yeah. Thank you.
Awesome. Thank you.
All right, it's unplugged? It's unplugged? Or is it too late now?
Oh, thanks. All right, can we have Insight up to the stage, please, and Astro Map on deck?
Hi, everyone. I'd like to introduce Team Insight. My name is Katie. This is Johnny, Stuart, and Joseph behind me. Working with this team actually has been amazing. They're each very talented, and we all have very different backgrounds. And I've honestly never laughed so much in 48 hours. So I apologize to everybody who sat near me. Coming together on Friday, we all had a lot of great ideas around space tourism that we were equally passionate about. But by about 2 a.m. on Saturday morning, we still hadn't settled on an idea that was unique to space. We thought a lot about what tourism would actually look like, but we realized the problem wasn't sharing photos or experiences thanks to Twitter and Instagram, like space selfies. So finally, we decided the problem was adapting to space, zero gravity, and orientation, knowing where you are and what you need to do while you're up there. What happens after the first week when the novelty of puking in a bag wears off, and then you know how to brush your teeth? So we decided on the concept that the next level of space tourism is an experience that provides you with a connection to your surroundings. So I'm going to pass it to Johnny and Joseph to explain how we plan on doing that.
All right, so I'm demoing the heads-up display that we were envisioning for space. So in the left bottom corner, there are two bars. This O2 bar that shows your oxygen, and this activity bar so that you don't get too active, tire yourself out, you sort of know what's going on. There is a clock as well down here, as well as your distance from the ISS. And at the top, if there's something that you need to know, you'll get a notification of some kind telling you, for example, to sleep or something, because you're not really used to space itself. If you wanted to, let's say, look around, you could point and go, all right, so like, what's over there? And we will bring up some contextual information and a picture from either the Hubble or some of the current databases for faraway objects, allowing you to explore the galaxy from where you are. And then, for example, let's say you're playing around with your friends, you can, let's say, you can click or point at your friend and you'll be able to get contextual information. All right, who am I pointing at? Because obviously it's really hard to tell. And then there is a navigation system as well, which John will explain.
Right, so let's say you're traveling with a couple buddies and you're doing a spacewalk together and you sort of lose sight of each other and you want to find him again. So through a voice command, you can issue something like, oh, bring me to Jim. And what this mini-map will do is actually set a waypoint to Jim. So Jim would be this little guy with the green arrow. So that would be your waypoint, and then the system would sort of direct you in how to get there. So it works the basic XY, sort of how a typical XY mini-map would work. The only difference being that you have these colors. So white means that you're actually on the same plane as your waypoint, and if it's orange, that means you're off. So it'll direct you actually in 3 dimensions. How do I get to Jim face to face?
So as you can imagine, this would make playing around in space and having a lot of fun really easy. Another thing that you could do is sort of look at nearby objects. You can sort of see, get a bit more information, or you're flying above Earth and you sort of, let's say I'm from Montreal, we will pop up a little waypoint showing you, all right, here's where your home is, and maybe a little bit of information about what's going on at the time.
So we made a few assumptions in this challenge. So number one, we're assuming that space travel is affordable, that tourists can venture out into open space using their suits and move around using propulsion jetpacks. We also assume that Wi-Fi and Bluetooth were available and that a typical vacation time is about 1 to 2 weeks. So technology we use, so this is a heads-up display solution. So it's not platform agnostic. So if you're out in space, the heads-up display would be on your spacesuit. If you're in the ISS or something, it'd be on some sort of goggles that are, Google Glass or whatever is fashionable at the time.
So Team Insight had a goal, and that was to make an impact. In time, space will become the new destination location for tourists. Insight caters to every type of tourist, from those who want to relax and enjoy their tour, to those who want to learn more and actively engage in their surrounding environment. The experience comes together while ensuring that all these tourists are monitored and safe. We want to gather a lot of data, everything from knowing what health effects come from that short term in space, and at the end of the day, push that data to NASA and then those coming to conclusions to help the future of space tourism.
So our next steps would be complete the app using native programming languages. For the purpose of this demo, we just use CSS and JavaScript, but we initially eventually like to use something like C++ or something that would be more platform agnostic. Validate the concept with proper experts in the field, and ideally launch a pilot program so that current astronauts can. Are we done? Oh.
Remember, guys, there's more to space than just the view, so never tour without insight.
Mike? Okay. Great start, guys. I think you have focused more on the applications of using wearable technology for space tourists and not necessarily engaging the public in sharing that, which is fine. The only thing I would say is, since that's the focus, maybe think about how heads-up displays, augmented reality, and interface on the heads-up display can help these tourists to adjust to the environment. As you know, there is a lot of problems with orientation, like you mentioned. So potentially, how could heads-up display build an artificial environment around the user in the first few days to be able to adjust to the multidimensional environment that they're exposed to?
Yeah, definitely. We have a basic idea of how heads-up display could potentially work in space, but not a full-fledged view of it. And that's why we suggested launching a pilot program so that we can get that application up there and see what problems current astronauts encounter with it, and then allow us to make the modifications that we need to do to the app, for sure.
So again, I'm gonna make some comments. I could see that as something, because we have robots that are called spheres. They're the circular robots that go around space station, and it would be really fascinating if those had that interface where as it goes around, it's like, oh, that's a wrench that we lost. Oh, there's my fork. because that's what happens in space. So it'd be really, I really like all the different things that you added to it. So just trying to think for now, between now and space tourism, there are some really interesting potential uses for that. I'm still thinking. Yeah. Did you have any questions? All right. Yeah. Good.
Thanks, guys.
Yeah, you might want this. Great job, Insight. Thank you. Next up, we have Astro Map. And CuriousBot, you're on deck. So CuriousBot, please come to this side of the stage, get all set up. In the meantime, let's hear about Astro Map.
Okay, ready? Yep. Everyone ready?
Let's do it.
No.
Oh.
Good afternoon, delegates and hackers and judges. My name is Jeremy, and I'm joined up here with two of my teammates, Jim and Peter, and we're Astro Map. So essentially, we're all strangers. We met on Friday, and we didn't necessarily know much about each other, which is interesting because then we found we needed to learn each other's strengths and weaknesses and then work on a project together. So the interesting part of this is that the dynamic worked out very nicely because we have two business students, two front-end developers, and two back-end developers. And we decided to work on kind of a merge of a project. The asteroid imagery sharing project, where NASA wanted us to create an open source platform for sharing images, and the visualize the asteroid skies, which kind of go hand in hand. So let's start up with our thought process. In space, there are approximately 1,000 close, near Earth objects that are more than 1 kilometer large. But we don't necessarily know much about the NEOs that are smaller. And as a result, they potentially pose threats to us. So some of the questions that we ask ourselves are, what can we learn from studying these objects? What are the implications of their patterns? And do we need to worry about Earth safety? And then we broke it down into some key challenges that we needed to overcome. And the first one being, how can we proactively track these large NEOs? And secondly, how can we discover and track smaller NEOs? Essentially, we're mandated with the task of consolidating this information into one platform that is available to everybody worldwide.
So Astro Maps essentially is an application that satisfies the need to track, map, and research NEOs by consolidating all existing information as well as continuously crowdsourcing input from our target market. Now the question is, who is our target market? We've been able to conclude that people who are passionate about astronomy as well as space, but also have the equipment that are necessary, equipment capabilities to actually gaze into space is a very niche market. The reason is because the level of investment needed is very high from a both personal as well as monetary perspective. As such, we are positioning our application as a community platform for people to share their passions with each other, to create an environment where people can collaboratively learn through each other's work. Now I want to introduce Bob. He works at TELUS, but apart from that, he's also an amateur astronomer, and his passion for this topic led him to build his own private observatory. Now, through remote Wi-Fi connections, people are able to tap into the live feeds of his work. However, right now, Bob uses Flickr, websites such as Flickr, personal websites, as well as real-life meetups to share his work with people who are also passionate about this. So the problem really is there is no platform that caters specifically to the needs of this passionate community, where people like Bob worldwide can share their work and passion with each other, which is why we have Astro Maps.
So we wanted to, we created a pretty functional backend, but our front end isn't completely ready. So what we've done is created a nice mock-up of what the landing page would look like here. And as you can see, you would see basically a star map, a map of the sky, and by clicking on specific points, you could see what asteroid or near-Earth object would be the closest to that specific spot based on calibrated values. So cool things to see would be estimated velocity and whatnot. And that picture would probably be crowdsourced from somebody let's say from Brazil or India, these guys that are really into their passion. And the second part that we wanted to introduce would be the browse function. And this is where people could really look at the raw data and research with each other in order to come up with new findings.
So we've talked about our basic functionality of this application, where we've kind of positioned it as an application that creates a worldwide neighborly community in this small application where people can communicate with each other as well as experiential learning. But the question is, what are the long-term implications of this? Well, over time, we'll be able to build up large amounts of data where institutions such as NASA is able to create predictive forecast models to kind of gauge potential threats of NEOs near Earth. Furthermore, we've identified the education vertical as an area of great opportunity. Because when you think of universities such as U of T or York University, they have these equipment set up to actually gauge into space for people to use. So by selling in our application and incorporating it into their curriculum, we'll be able to promote more exploration and further usage.
So to summarize, we come up with those questions at the beginning of our task. We broke it down into two issues that we wanted to solve, and essentially the Astro Map community is able to overcome these challenges. And what we really wanted to accomplish was to create a global space where passionate space lovers can come together and explore. So with that, I'd like to thank you for your time and open up the floor to any questions.
Hi. This sounds to me like Instagram for asteroids.
Yes.
Yes. Was that where you got some of that inspiration, or is that where you got some of that inspiration?
Yeah. Right now, we've identified that. Right now, when you look at certain platforms that are open source for people to explore space, kind of get data and everything, it's more catered towards the professional fields where scientists are able to grab this information and stuff. But we identified this kind of opening in a market where amateur astronomers are also passionate about this field, but they don't have the necessary platform to share this passion with each other, which is kind of where we got the inspiration to create, I guess you can call it a Facebook for amateur astronomers to kind of merge together and like collaborate together, because there is no platform right now that exists catered towards the amateur market.
So is the idea to have all of this information in one place, and who would own this information?
It's open source.
Okay.
Yes.
All right.
So that was my question, is this a database, or is it pictures and with some information about the pictures? Back to spaceweather.com.
Yeah.
The people send in their pictures, it gets archived there, and they have all the specs of where they took it, when it was, what the camera looks like. Is that kind of what you're thinking of?
Yeah.
Okay, so you would have a database or just like a Flickr archive with data? I'm just curious how you saw that, because it could be unwieldy if you're trying to keep them all. So I'm just curious.
Well, yeah, it is a pretty substantial database. One of the key things was it's also part of a request, kind of a request from the Minor Planets. They talk about they've got a big database, but there are no pictures. So I got this distinct impression from the Google Hangout that they would really like to have pictures. And this is basically, frankly, that would probably be the host, ultimately, of this, would be the Minor Planets.
Okay. Thank you.
Thanks, Astro Map. Next up, we have CuriousBot. Rosa, you're on deck. Rosa, you're up next. Please come to the side of the stage and come on up, CuriousBot.
Okay, you got a mic?
Okay, welcome to Chewy Spot. My name is Artash. I go to 2nd grade.
Hello, my name is Abuti and I go to Maternelle.
And I'm Rati. I'm an environmental scientist.
Hi, I'm Vikas. I'm also an environmental science background.
Saturn 10 rocket is launching in 2000, carrying a curious spot with it. Now it's landing on Kepler 1b exoplanet. And here it is.
This is the curious spot.
This is the curious spot. Yeah, it landed, so. Okay, so it has 3 stages. The first one is it's going automation with the modals. So it's auto. The second stage is with the sensors. So it detects and guides the modals. Third stage is the communication system. So it communicates like with that antenna kind of thing there. So it transmits the data to like your ground station.
Yeah, so we have, can you see it?
You can't see
Oh, it's not.
the presentation.
Okay. It's coming up here. So, yeah, so there are basically, we have created a curious bot which has 3 different modules. First one, as Artash told, is a Autobot. Basically, we want the robot to be self-driven, basically. So it can go on its own. I mean, there's no guidance, basically. Once you land it up, it can start on its own. And so it can go everywhere. And then it has the sensors on it. It can collect temperature, moisture, magnetic field. It can collect and it can also collect the flame, basically. So and then the best part is also that it's able to transmit the data using wireless, basically. We have set up a wireless data. And you can get the coordinates. So it's sending out the wireless data up there. You can see that. So it's collecting the temperature. It's the temperature is 22 degrees centigrade, and the humidity is 33. So it's sending data wirelessly through the radio frequency. So these are the 3 different channels in which we have created the Autobot. And these are the 5 sensors we have: infrared, humidity, temperature, flame, magnetic. So if there is a flame, basically, it could tell and the last one is bring focus.
Basically, our aim here was to demystify technology, sort of bring science to the non-technical masses and to spark interest in science, especially in kids and their families. So that was our aim with this. And hopefully this is something that we could use in classrooms as well. Thank you.
And it costs $60 basically, get the part from China basically, So the kids can make it and break it. I mean, we broke so many of the Arduinos. Arduinos basically, we have used 4 stacks of Arduinos there. And, so. 3, sorry. And And so yeah, the parts are very cheap, and even SEC kids can make it on their own. Thank you.
Just wanted to tell you I love it. It's a great family activity, and because of that, one thing you might want to think about is thinking of it as a workshop opportunity to do in public places like schools or museums, or again, looking at kits or activities that people could do on their own as a family, because that is really a good place to start in terms of spreading communication about science and the potential to think creatively. Great idea.
I think that you'd be really great if you worked with weather mesh, and then if you had roving microgrids all around, because you could send that around and gather data in the city on wherever it is, which I think would be super awesome. And I think this is a really great People's Choice Award. But I didn't say that. Do you have any other questions?
Thank you.
Okay, this is.
Can you remove that one, please?
Yeah, absolutely. Oh, you got it?
I got
You can
it.
come
Thank
back.
you. That's okay. Thank you.
All right, Rosa is next, and can we have Oculus Spectaculus to the deck, please? Take it away, Rosa.
Alrighty. Thank you. Good afternoon, everyone. It's so great to see you all again, and so many new people. That kid intimidates me. So my challenge that I chose was the greenhouse for Mars, and I decided to do a conceptual model. I work as an apprentice architect, so coding is not my game. That's for you people. Okay. Mars. Now, for the deployable greenhouse, it has to be pre-deployment before the astronauts get there. I've chosen a specific spot, Hellas Planitia, a very deep crater from the early bombardment period of the solar system. The atmospheric pressure there is enough that it's past the triple point for water, so liquid water can exist there. I don't believe we've ever landed there. I'd sure like to. So again, that's that blue spot. They think it used to be a sea back in the day. Now, I don't know if anybody eats algae. I don't. I'm sure it's not great, but in health food stores, you see it everywhere now because it is such a powerful supplement, almost 43% protein, so it's not bad, but anyway. So here's my conceptual greenhouse. I made it as a drone instead, so it can fly around this gigantic crater. Again, that's it folded out. Before was when it first lands. I want to expand this with maybe hydrogen or helium. I have an aluminum frame base, and within, you can kind of see it. Those are the algae jars. That's an aerial view. There you go. Okay. So we're going to ferment this algae in here. It doubles its biomass at a rate of double every 8 days. So 8 meters squared produces enough oxygen for a fully grown adult male, which is pretty good. It works similar to these. So we have this technology. It's very simple. It's algae and water. If you've ever had a pond, you know. Here it's a pellet type form. Here's my artistic rendering of it. So it's not very clear, but you can see it's flying, and it's not an actual image. I drew it. So one day, that's what I'm hoping for. So I wanted to talk a bit about the different skill sets we have here, all the coding, and like I said, for me, that's over my head. I can't do that. My job is to start a seed of inspiration in somebody and for them to take it on to the next level. So if anyone wants to think about this, go ahead, it's yours. And one day, together, Mars with water. Ladies and gentlemen, that's quick, but the rest is for you to do. Thank you.
I have a couple of questions. One is why algae? I know you touched on the
Well, or none.
Or no more jokes, hopefully. Oh, yay. Excellent. Okay, we're good to go, yes? Yes?
We have some people walking around and talking stuff. Can we pay attention to our last people? We're so close. We're so close.
Hello.
There we go.
Those at the back speaking to each other, enjoying their coffee and cookies, and okay, they're just going to ignore me. That's fine. I can't believe they're eating cupcakes first. Okay, so my name is Jonathan. I'm here with my 4 friends from the University of Toronto Computer Engineering. Wisey's over here helping me with the demo. Michael, David, and Zachary are down in the audience waiting. While we do the presentation, I'd like to invite one of our esteemed judges to come up and fit the Oculus Rift headset for the demo. Yes, please come up right now, and fit for the demo while we actually go on and describe our project. So our project is piloting a satellite. So kind of show of hands, how many of you have piloted a satellite before? Okay, you guys with your hands up did the demo before, so that's why. But you know, one of the challenges that NASA presented to us was what would it be like to pilot a satellite? And you know, since not all of us can be Chris Hadfield on the International Space Station, we wanted to give you an opportunity to kind of put yourself as if you were standing on a satellite, clinging onto one of the edges, looking out on Earth as it was orbiting. How do we do this? You know, now that we're living in a virtual world where everybody has their heads down in their smartphones, we actually also have this thing called the Oculus Rift, which is a virtual reality headset, which one of our esteemed judges is now demoing for you. Using the Unity 3D game engine and this Blender technology to create some models for our satellites, we actually were able to recreate kind of a very rudimentary space simulation. So without further ado, I'd like to go to the demonstration. And here we go. So this is what our judge can see right now. Oh, sorry. Turn your head. Is it working? Okay. All right, so you are on the ISS. Is it the ISS? Oh, this is the ISS. Okay. So you are currently going 7.7 kilometers per second around the Earth. You can see the ISS features around you. If you turn towards the Earth, that green is the orbital path of the ISS. You can see a beautifully rendered model of the Earth spinning around. Hold for 1 second. I'm going to switch you to the Hubble. Hubble's good or no? Kepler. We're going to switch you to the Kepler. So this is the Kepler Observatory. You can see off in the distance there is the moon. You have a different view of the Earth. And for our grand finale, this technically is not a man-made satellite, but it is a satellite in the most technical sense. You are now on the moon. And you can see the green and red trails of the ISS, the Kepler, and the Hubble Observatory as they orbit the Earth. So as you can see, we created a realistic space environment using Unity. We have a custom orbiting algorithm. All of these actions are actually done to scale, so the moon rotates at the correct speed, the satellites rotate at the correct speed, and there are satellite trails that we use so you can actually see where the other satellites are. We think there's a lot of opportunity for this type of technology in museum simulations, education, kind of training. Thank you. Training for maybe space tourists if they want to get a feel for what it would be like to be out there and orienting themselves and learning about reference points. Thank you. Thank you. And that's mostly it for us. Thank you. I'd like to invite the rest of my team members up for question and answer. Thank you.
I seem to be speaking softly. Anyways, I just wanted to let everyone know that the rendering while I was wearing the headset was very well done, so it looked very, very real. You talked about simulation and being used in simulations. Can you talk to me more about that? Like, what have you thought about in terms of whether this is being done here or in space?
Sure. So, for instance, we could see something like this being deployed in something like the Ontario Science Centre, even an interactive exhibit for kids, young adults, even adults. You can see, even everybody here we've demoed it to so far has gotten a really big kick out of it. You can kind of look at the different features of the satellite. In the future, we might have GUI elements overlaying that say which satellite you're on, how fast it's going. You can look down on the Earth and see individual reference points and maybe do some zooming. So this demo we have here is only for Earth, but you can also have satellites that are orbiting other planets, perhaps in the asteroid belts, and do similar things that you would have in kind of a downstairs. There's the planetarium with the overhead concave display. You can kind of do that here as well with basically $300 worth of technology, and it's very accessible. More so than, I believe, the Planetarium Observatorium. So I think for that type of simulation, it would be really great.
Right. Did you think about any other type of interaction with the simulation in terms of other? I mean, you said that they could find out more data on what they were looking at. How would you?
Right. So definitely outside of kind of just educational uses, we think we can also perhaps overlay some weather simulations, like real-time weather mapping on over different parts of the Earth, so you can observe cloud movements or perhaps weather movements. In terms of possibly the virtual reality technology, of course, can be extended to provide actual training for spacewalks, or if you wanted to virtually perform some sort of technical operation on a space shuttle like Sandra Bullock was doing in Gravity. You could do it without actually going out there. Yeah. Any of the other questions?
You told us we were done.
Thank you.
Nice job, man.
Good job. Good job, boys. Good job, boys. Proud of you.
Good job, guys.
Thank you.
That's great.
Oh, sorry. Hello? If anybody wants a demo afterward, because it's really hard to see on the screen, feel free to come. Thanks.
We did it.
Yay!
Yay!
Congratulations, all the teams. Okay, well, thank you for everyone who worked incredibly hard. So just before we continue, one reminder, let's do the People's Choice at some point in the next hour. While the judges are deliberating on their picks, please deliberate on yours. You can, oh, Matt, can we get this splash screen up? Can I push play? I did push play. Play. Okay. The URL that's about to come up, go ahead. It is on the honor system. One vote, please. One vote only. Thank you. And only Space Apps participants and volunteers, please vote. Don't send this to your family. So it's bit.ly/whatever's here, and you have 10 seconds to get it down.
Do, do, do.
We'll put it again at the end. How about that? We'll just put it again at the end. Okay, we'll do that. So before we announce what's going... Read it out. Okay. 1, lowercase m as in Mary. 0, lowercase r as in Richard. 1, 3, D as in David. Good? All right, great. Okay, before we talk a little bit about what's going on in the next hour as the judges deliberate and all the shows that are going on in the Science Center, let's just do a quick... Let's just wait. Let's just wait. Okay.
Are you done, Science Center?
Thanks, Science Center.
Okay.
All right. A quick thank you to our sponsors. So again, TELUS, thank you very, very much for the internet. Really, really much appreciated, and the support. To our host sponsors, of course, the Ontario Science Centre. James from the Fuse, Matthew, who handled all of the AV for the weekend. Thank you, Matthew, and HTML5. And for MakeLab, who generously sponsored the 3D printers for the weekend. Our Discovery sponsor, Architect. Our Orbit sponsors, the Toronto Public Library, who was the venue for our Beer and Post-its event. FreshBooks, who have donated the cupcakes at the back for a refresh.
There are cupcakes, just for those who haven't noticed yet.
And, money also for pizza.
Yep.
And Autodesk, another one of our amazing Orbit sponsors who helped us provide everything we needed, including food and drink. Our launch sponsors, Shopify and Denton's.
And all of our awesome community supporters. We couldn't have done it without all of them. So go to our website and check them out if you're not familiar with them.
Okay, so the judges, you have 1 hour to deliberate. Tally your things, use your abacuses. Abacuses? Abaci? I don't know, abacuses. You have 1 hour to deliberate. During that hour, there are private planetarium shows for us and us alone. At 5 o'clock, the first planetarium show, Extreme Universe, which some of you might have caught the day before. If you haven't, 5 o'clock. At 5:30 or 5:35, we've requested our second private planetarium show. This will be the toddler show, specifically designed for toddlers, and I have... You got it. Do you want to speak a little bit about it? Yeah. Our visionary planetarium host.
Wow. Hello, everybody. It's a good weekend. Super productive, I'm sure. My name is Jesse. I'm going to be doing the planetarium shows for you. We have 2. You wanted to do 2. We're going to do Extreme Universe, which is literally a tour of all the extreme things in the universe, which is wicked. And then give you, I've been told you want to see our toddler show, which is the one we do for the little wee ones. It's absolutely adorable. Maybe not for you, but the show is great. And I think if you really want to see it, I'm absolutely happy to do it. So, do you want me to say any more about it?
Well, you promised to deliver it just the way you would real toddlers, right?
Treat them like toddlers?
Yeah.
You want me to treat you like toddlers? Done.
Okay. Thank you, sir. And while the Science Center has closed in general, we have gotten special permission. We get the run of level 6? No, the space level, right? Just the one level below this, where the Kid Spark is and the space stuff is. Enjoy that level. The Kid Spark has this awesome like waterfall thing. Enjoy it. Have a great time, and
Just be back at 6 and find out who wins.
thanks, everyone.